Up to now, we have looked at data of a single table, and of course, in a relational database system, the information is spread among different tables, as we have also seen in our examples. And now I'm talking about how to combine data from different tables. So the general idea is, instead of looking at the table as it is with the foreign keys, for example, for the playlist and for the genre, we would like to see the actual playlist and the actual genre. Yeah? And this information, for example, the name of the playlist and the description of the genre here, that is in different tables. That means we have to combine information of many tables, and we need some kind of operation in order to do so. The problem here is that combining tables, if we look at our specific example here, we see that neither the number of records nor the number of columns of those two tables or those three tables here are the same. So we need some kind of operation that is able to handle this situation. And there a specific mathematical construct comes in handy, namely the Cartesian product. I assume all of you have already heard of this. If not, it's quite simple. We have one set called S1, and this set has three elements, A, B, and C. And we have a second set, S2, and this has the members 1 and 2. And the Cartesian products, that's designated by this cross here, yeah. The Cartesian products of set 1 and set 2 is that set here. And if you have to paraphrase it, what is the content of that set? How you could describe it?
It's like a matrix.
I want so that the question was so the answer should just tell me what is the contents here. So not so a matrix is not the correct thing here, but how would we call such thing here?
A one-to-one relation.
Yeah, that's so the general name for that is just a pair of values. And the Cartesian product is just the set of all pairs of S1 and S2. And that means the set of all combinations of values from set S1 and set S1, S2. Yeah, you see A1, A2, then B1 and B2, C1 and C2. And that's all the combinations. And now you get an entity here, S1 cross S2, that contains the information of both sets. Yeah, and this is also the idea behind combining information from different tables. So so if we take, for example, if we take the title table and the playlist table here, and we would like to combine the information of those two tables, let's take the Cartesian product of these two tables as a first step. That's not the whole solution in the end, but that's the first step. So, and how could we write that down? We could just write select star from, and now I take a title and then I say cross join. Let's reformat it a little bit. Cross join playlist. And if I execute this query, what do you think, how many records we are going to expect? What do you think? So maybe we should take a look here again at the cross join. So set number 1 has 3 records and set number 2 has 2 records. And if I take all combinations, I get 3 times 2 records. That means 6 records. Yeah. So if I take the cross join of the contents of this table with the contents of that table, what do you think? How many?
57.
52.
52.
52
Yeah?
records.
13 times 4. These are the combinations. And let's do it. Yeah, you see here, you see number 52. That's the number of records that are in the output here. We don't see any. We don't see all, not all records in the result fit here on the screen. Yeah, but if I scroll down, we can see we see it goes up to number 52 here. Yeah. So now let's see what we have here. So let's first take a look at the columns. There you see we have the SID from the title table. Then we have the name from the title table, the durations in second. Then we have the playlist ID here from the title table, the genre ID from the title table, and then we have the playlist ID from the playlist table, the name from the playlist table, and the last call from the playlist table. PLID, name, last call. Yeah. So first of all, we get all columns of both tables. That's the number of, or that are the columns of the result of that expression here. And now let's take a look at the rows. So for example, we see sit back 1 combined with chill out. Yeah, you remember Cartesian product means all combinations. We combine I will fade with chill out, and this is done with all 13 records here from the title table. Then the 13 records again are taken and are combined with dance out. You see 13 combinations with dance out, and so on, hard and heavy and epic. Yeah, so that's so we have all the combinations here. That's now the Cartesian product, and now you see that the result of this Cartesian product is one table. Yeah. Now we have combined the information of 2 different tables into one large table, but of course that doesn't make quite sense here, because all combinations are not interesting. But we have a further operation that we could apply on this resulting table here, namely the filtering. We could filter out interesting combinations. And what do you think? What are the interesting, the relevant combinations of all the combinations here? Which condition should they satisfy?
Both the PLIDs are same.
Yeah, exactly. The PLID must be the same. And that is something that could be written down quite easily. Just where. And now we have to, since the playlist ID, you see it's in both tables, if we are referring to them in the SQL query, we have to make it unique. So we have to say title dot pl title dot plid, yeah, equals playlist dot plid. Yeah, so we are filtering out all those records that where the playlist ID is the same. And if you execute that here, now you see we get 13 records back, and that makes perfectly sense, yeah, because we have 13 records in our table. And let's assume we would like to only see what was our expectation here. It was okay. Also the genre we just keep here. We at the first step we stick to title and playlist. I will come to the genre later on. So we take the name of the title, yeah, and then we have the, I would say, description. No? Or what was it? I forgot it. It was the name is also duplicated here. So we have to say title dot name, yeah, comma playlist dot name. So let's execute it. And now we have it. Yeah, now we have combined the information from the two tables and see the corresponding value in the output. And maybe you remember our first lecture at the beginning of the semester where I have talked about Excel sheets, where we have redundancy in it. For chill out is for example, is many times here in the output. Yeah, so actually looks a little bit like an Excel sheet now, but now on a completely different basis, because it is calculated out of the database. Within the database, everything is non-redundant. Chill out is only one time here, not many times. But using SQL, we can reconstruct our Excel sheets in some sense. So, and therefore I have, if you look at the title of the slide here, I have called it report without foreign key. And the idea is that such kind of thing here, so this one here, that this is a report. That is something that you use in a meeting to show other ones. Yeah. Of course, if you are in a meeting and you show data, you don't show foreign keys. They are meaningless for the other ones. You show it that way as in Excel sheets. But in this case, it is derived, and therefore everything is fine. Yeah. So the essence is the combination of data from different tables consists of cross-join plus filtering. And since this is the standard operation to combine tables, there is a specific name for it and a specific syntax for it, and it is called join. It's a join operation. We are talking about a database join, and actually there are two kinds of joins, namely inner joins and outer joins, and we are going to start with the inner join. Yeah. Just a moment here. Okay, the inner join. And let's rewrite it correspondingly. So the way how it is written is as follows. And that's now our join. So I execute it again. It's the same. So let's see what we have here. So first of all, now after the from, there is not a single table as we have had it before, but there is a combination of tables via the inner join operation. So table 1, inner join table 2. So title inner join playlist. And in order to be a correct join, we need to have a join condition that tells us by means of which columns the data is connected or has to be connected. And this is after the keyword on. So we have to use the keyword on. And then we have to provide a join condition, namely the playlist ID of the title must have the same value as the playlist ID of the table playlist. No? And that's our join. And actually, there are we could do some abbreviations here that delivers the same result. Namely, we could. So it's the same query. I'm going to rewrite it to shorten it a little bit. First of all, the keyword inner is optional. So if you just say join, it's equivalent to inner join. Yeah. So if I execute it, it still works. And then you see here we have the table name used here in order to unambiguate the columns, in order to make them to reference them in a unique way. And in order to shorten that a little bit, you could also give it rename the tables within the query. So I just could write T title T. That means the table title is renamed into T, and playlist I rename it into PL, and then I use T.name, PL.name, T.name, PL.name. Yeah, and that's perfectly equivalent. Yeah. So this is our join. So
I guess we used as for allies, but isn't it necessary here?
It isn't necessary here, and I think it could also be done. Let's see if it works. The point is, from a standard SQL, it should be possible, but in Oracle, for whatever reason, the keyword as is not possible here. You use the keyword as in the column, but within the table, you use just you put just the renaming without any keyword, yeah, right to the name of the table.
Okay.
Yeah. Okay, so just a moment here. I would just want. Okay, yeah, this now is our join, and I will put it in the chat here. Both versions, yeah, and just try it, yeah. Please remember that you have to use the correct schema here, UPL MBA, and then you have the two versions here. Both are the same.
Professor, I have a question.
Yeah.
When we're naming a T name and PL name, or choosing the columns, then I mean, won't it be confusing if we put it like name? Can we rename it? And
yeah, of course. Yeah. So this here is as title. Yeah, that's a good remark. Title, yeah, and this is as playlist. Yeah. Now it's much better. Yeah.
Professor, I'm getting an error for this. So can you please tell me what's wrong with this query?
Yeah, title is, let's see, what is the error here? Title name, title SID, from title inner join. Yeah, inner join, your table is missing. From title inner join playlist. I will copy it over here, yeah. So this was Niraj. This was yours here, yeah.
Mm.
And the point is here playlist is missing. So table name, inner join, and then you need also the table name playlist, yeah.
Okay.
And then PL, and then you have then the keyword on, and here you have to use equals.
Ah, okay.
Yeah.
Yeah.
Yeah, please, all of you try to execute it. And if you got an error message, please ask me. So the general structure is name of table, inner join, name of second table. Yeah. And so you don't have used abbreviations here. So name of second table and then on. Yeah. So let's execute it here. Yeah, it also works. No error in it. So now the syntax gets more complex, as you see, yeah, because of this additional thing. But of course, joins are absolutely fundamental within the relational data model. They play a most important role there, yeah. Okay, so this is the join here that we have seen, and now let's talk about the join a little bit.
Professor, can you please post the renamed version? I mean the edited version.
Yeah, with the new names. This, yeah, okay. I think this one here, yeah, they would like to have. Was it that one?
Where we named the like columns as
Yeah.
name as
Yeah. Copy it into your DB visualizer, execute it, and you will see it. Okay, so let's talk. Now let's dive a little bit more deeper into the effects of the join here, and I have provided an abstract view here, yeah, in order to look a little bit closer at it. So first of all, we have two tables here. One is called R, and the other one is called S. And table R has two columns, A and B. And table S also has two columns called C and D. And these are the records: 10A, 100B, 20A, 200B. These are the two base tables here. The join I'm going to carry out is select star from table R, join table S on column B should be equal to column D. That's the join condition. No? And now if we execute that query, we can proceed in a Cartesian product manner. Let's do that, yeah. So let's copy this one here. So that we could save it. And now let's clean that here. So let's first of all calculate the join by carrying out the Cartesian products and then the filtering. Yeah. So if we carry out the Cartesian product, we are taking 10 and A. 10 A. And we take that record here and combine it with the first record here from table S. That means 20A. Then we take the same record here, 10A, and combine it with 200 and B. Now we are now carrying out the Cartesian product here. Yeah. And what is the next row? Who tells me?
100B,
100A,
100
B,
B,
20A.
20A. And the fourth?
100B or 200B.
Yeah. 100B and 200B. Yeah, this is a Cartesian product. B, yeah. And now we do the filtering according to the join condition. B should be equal D. Let's take the first record. Is column B equal column D?
Yes, yes.
Of course. So we keep it. Second record. Does it satisfy the condition B equals D?
No.
No. Remove it. Third record.
No.
No. Remove it. Fourth record?
Yes.
Yes. You see it? So we do the yeah. So of course we are not carrying out the complete Cartesian product as I have done it here manually, but we can do it directly within our head. So take the first one here, look at the first one here. Do they fit? Yes. Put it in the result. Take the first one here, look at the second one here. Do they fit? No. Do nothing. Take the first one here, combine it with the second one here. No. Second one here, yes. Here we are. Yeah? That's the way how we deal it. So now I have taken the same tables again, but as you see, I have changed this second row here in the R table. I've switched from B to A. So now let's carry out the join again. So taking the first record here with the second record here, first record here, they fit. So 10A, 20A appears in the result. Let's take the first row here and the second row here. No, don't fit. Let's take the second row here and the first row here. They fit. 10A, 20A is in the result. Let's take second row here, second row here. A equals B. No, it's wrong. So it's not in the result. So we get that result here, yeah? Is it clear how I've calculated it, or are there some questions? That seems to be clear. So now we can draw some observations concerning the effects of the join. First of all, you see 200B doesn't appear in the result. And that's because it is not connected to any row of table R. And the inner join behaves in that way. Only records that are connected via the join condition appear in the result. And if I have a record in any one of those tables that is not connected to any one of the other table, it doesn't appear in the result. Second, if a record is connected many times with a a record with different records from the second table, so it is connected many times, then as many times as it is connected, it will appear in the result. So if you look at 20a here of table S, it is connected with 2 rows in table R, and therefore it appears 2 times. Yeah, and that is what is happening here. And this is something you have to keep in mind, that's the effect. And if we look back here at our example, and let's stick here to the best one, yeah, this one here. You also see here, since the playlist table is connected 1, 2, 3, 4 times. The chill out record is connected 4 times with the title table. It appears 4 times in the output. So if you look at the actual data, so we have one record here, chill out, and it is connected with this one, with that one here, with that one, and I forgot here, this one, that one, third one, and fourth one here, yeah. And since it is connected 4 times, it appears 4 times in the result. No? Okay, so that's the general effect here of a join. Are there any questions to that? Okay, then let's go ahead. So again, let's talk about the structure of a join. So if we have 2 tables, we'd simply say table 1 join table 2 on the join condition. And if we have more than 2 tables, then we say table 1 join table 2 on, and then just go ahead with the second join, table 3, and the second join condition. So that's the way how tables are joined here. If we have more than 2 tables, and if you remember here, no, this one. If you remember here, the my first slide here, actually we would like also to see the genre here, yeah. And so how could we do that? We just add a further join, and now we join the third table, namely the genre table. Call it G on, and now the join con table has to follow. And maybe some of you can tell me how the join condition looks like. What should be the join condition here?
T.glid is equal to
So
G dot
T dot GID.
Yeah, equal to G dot GID.
Yeah, that's a join condition. Yeah. So
GID.
GID, of course. Yeah, and let's add here description. Yeah, G dot description as genre. So let's first execute it, see if everything is correct. Yeah, that looks good. Yeah, and an important point here now is, so we are carrying out 2 joins, as you see, and no, wrong one, no, so this one here, and you see in the first join with respect to the playlist, we are combining PLID with PLID here. And in the second join, we combine a GID with GID, and that's really important to understand. You can only compare, for example, foreign keys and primary keys that have the same meaning. The foreign key playlist ID, that's so playlist ID as well as genre IDs are integers. So from a technical point of view, I could say something dot play PLID equals something dot GID. So technically that would be possible, but it would be meaningless because it only makes sense to compare playlist ID with playlist IDs and to compare genre ID with genre IDs. Yeah, that's important if you're carrying out joins, that the join condition must consider the corresponding and fitting connections. Yeah, that's what has to be done and has to be considered. So now, if we look at the output here, you also see an example of this second effect. You also see examples of the second effect, this red one here. What is an instance of that effect here, of the second effect? And let me show you again the playlist table. That's the playlist table here, and here we have the genre table.
So we don't get any epic, any genre with epic because it doesn't exist.
With which we don't have any connection?
With the fourth genre, epic.
Yeah, and which genre is affected?
Sorry, folk, I mean.
Folk. Yeah. So since folk is not in connection, not connections with any title, you see that folk doesn't appear in the output. Yeah, and that's exactly this effect here, that something is not connected. So this slide here gives you the general idea of the effects of the join. Yeah.